So we're going to take a look at 1.3 part 1. Okay, so this is on a little bit more with solving equations. But we are going to talk about something that didn't happen yesterday, which is what happens when all the letters in an equation cancel out. Well, one of two things can happen. So we'll take a look at both cases. All right, so we're going to have problems where you're going to have like terms, okay, that you have to combine. You're going to have variables on both sides. Okay. So let's just kind of go through a reminder of those steps. What's that word again that we use to remember the order? Sam. And under the, we wrote these down yesterday. Under the S, you don't have to write it. You don't have to write it again. What's the first thing we always look for? Yeah.
Simplify.
So, yep, S is simplified.
I
should write that down. And then the first thing you do under simplify? Yep, if you have it, and we did yesterday. We already wrote it yesterday, so just a review. Yeah. So if you don't know it, I would write it down, but if you already have your notes from yesterday, you should be all set. And then after distributive property, what do we do there? Right, CLT, right? Combine like terms. Okay, so that's the first two things we do. How about the A? That stands for any.
So do we write this down?
It's up to you.
Okay.
Yeah, it's up to you. What's the A stand for? Yep.
Addition and subtraction.
Yep. So any addition or subtraction. And then after we handle any adding and subtracting, we finish up with, yep.
Multiplication or division.
Yep, multiply or divide. Okay, so that's the order we always go in when we solve equations. We've done it a couple times now. We wrote this all yesterday. So. All right, so let's try example 1. Okay, so I'm going to give you guys a minute or two to try that one. Okay, and we'll walk around, and if you have any questions, just let one of us know. And if you want to check your answer, just call one of us over. Okay, so whenever you have variables on both sides, you have some choices about how you solve it. So I'm just going to ask you guys, with the simplify step, did you have to do that here? No, there was no distributive property, and there was no combining like terms on the same side. So now we're going to go into the steps that move things from left to right or right to left. Adding or subtracting? Was there any adding or subtracting that people did first here? What did you do?
I did 2p, I did negative 2p, and then negative 2p on the other side.
Okay, so yep, subtracted 2p from both sides. And when you do that, what's 2p? Take away 2p.
0.
Yeah, that's gone.
Okay, 12.
So all we have here on this side is 12. And then what about on the left side?
3p minus 9.
3p minus 9.
And then what I did was plus 9.
Okay, so then we still have more adding or subtracting. You usually have that step a couple times when you have variables on both sides. So you add the 9 to both sides. All right, so negative 9 plus 9 is 0. All right, what do you have now?
21 on the right side.
21 on the right.
On the left,
And what on the left?
3p.
3p. Okay.
And then I just did 3 divided on both sides, and then I got the same.
Yep, and then because 3 is being multiplied by p and we want to get rid of it, we're going to divide. And we're going to divide each side by 3. And 21 divided by 3 gives me 7. So that's one way that you can solve this one, by putting all the p variables on the left side. Any question on solving it that way? Now, did anybody solve it where they put the p variable on the right side? No? Well, let's try it and just see if it comes out the same. So 5p minus 9 equals 2p plus 12. All right, so now instead of moving the 2p to the left, let's see if we can move the 5p to the right. Anyone think they could tell me how to do that? Yep.
So you subtract 5p from both sides of the equal sign.
Okay, so subtract the 5p on both sides. All right, what happens on the left?
You get negative 3, where
So on the left side?
on the side with the 12,
That's the right. So we'll get that one. But what happens on the left first?
so the negative 9 stays there.
Mhm.
And then it turns into a negative 3, right?
Anything else that cancels on the left? So the 5p minus 5p. So that cancels out.
Yeah.
Yeah, so that's gone. So we have negative 9 that's on the left. And then what's on the right side?
It's negative 3 plus 12. Negative 3p plus 12.
Yep. Negative 3p plus 12. Okay, so now we've got all the variables on the right. So now we need to put anything without a variable on the left. So what has to move to the left side?
P has to go down.
I missed
Oh,
it.
P's already there.
Yeah, I got the p. Yeah.
The 12.
Yeah, the 12 would have to go on the left side. And how would you put the 12 on the left?
Subtraction?
Yep, you'd subtract. And what would you subtract on both sides?
12.
Subtract 12. And subtract 12. Positive 12 minus 12 cancels. What's negative 9 minus 12?
Negative. No, positive. 20, yeah, positive.
If you had 9 plus 12, that would be 21. But this is negative 9 minus 12.
So it would be negative 20.
Negative 21. Yeah. So negative 21. And then on the right side, you would still have
Negative 3p.
negative 3p. And now the multiply or divide step, what would be the last operation? Multiply or divide?
Divide.
Yep, divide. And what would you divide each side by?
Negative 3. Negative 3.
Just negative 3. Negative 3 divided by negative 3, that cancels out, and you get 1. And then on the left side, what's negative 21 divided by negative 3? 7 equals, and what's on the right side? 8. So, how did doing it that way compare to the first way? In terms of the answer we got.
It's the same.
Yeah, it's exactly the same answer. I think in terms of maybe the steps, the left way was probably easier for people because it dealt with all positive numbers. We didn't have to deal with the negatives. But you can see the work I wrote down in terms of the steps is identical. It's exactly the same amount of work, no matter which way you do it. All right. So that's one thing you have to decide when you're solving equations with variables on both sides. Which side do you want to put the variable on, the left or the right? If you do the steps correctly, you'll get the same answer both ways. But I usually think one way is easier. Okay, any question on that? All right, so what can happen when we have variables on both sides? Well, it's possible that when you go to solve an equation with variable on both sides, that some equations have, and then in the blank line, you want to fill in no solution. That means when you try to solve the problem, you realize you can't do it, that there's no solution to the problem. And we're going to see what happens in that situation. Now, The opposite of having no solution to the problem is having, infinite, or any number is a solution. So while for other equations, you're going to write down any number is a solution. That's what goes in the second blank. So while for other types of equations, you can have any number be a solution. That means no matter what number you plug in, it's going to work. Now, if you're solving an equation where any number is a solution, that type of equation has a special name. So where it says if any number is a solution to an equation, you want to fill in what I just underlined. That type of equation is called an identity. So an identity is an equation where every single number is a solution. You can't find a number that wouldn't work. Every single number works. Okay, so you guys just have to write in the underlined parts. Everything else should already be printed for you. So I'm going to give you guys a second to try example 2. See if you can see what's going to happen. And then we're going to write a little bit under example 2. Like we're going to have to write like a sentence in there. Okay, so make sure you leave a little bit of space to write that down. Okay. Does everybody have what they need to write in for the blanks? Okay. So I'm going to give you guys a second to try this. Okay, and this, again, might be a good one to do in pencil. In case you make a mistake, you can erase it when we do it and fix it. But try to solve it and see if you can figure out what's going to happen. When you get to a point, if you get stuck, just call one of us over or have us check it out, and we'll help you with what's going on. See what happens. Okay, so my suggestion here is the first thing you always want to do is get all your variables on the same side. So do we want to try to put all the x's on the left side or the right side? We just have to pick a side.
Left.
Okay, let's put them on the left. So that means we need to take this one and get it over there. How would we move the 5x that's on the right side over to the left side?
You would subtract 5x.
Yep, so we're going to subtract 5x on the right, and we also have to do it
On both sides.
on the left. Okay, so now on the left side, 5x minus 5x cancels out because we get 0. And 5x minus 5x on the right, that cancels out. So this is something that never happened yesterday. All the variables cancel. What's on the left side?
4.
Just the 4. And what's on the right?
Negative 3.
-3. If all the variables cancel out, you're done doing steps in the problem. At this point, we just have to look at that and figure out what's going on. 4 equals -3. Okay, what do you think about that? Yeah?
Solution.
Right, so what's happening here is we have a different number on the left than we do on the right. 4 is not equal to -3. That's false. That's not true. If you end up with a false statement when you go to solve an equation, that means it's impossible to solve the problem. And that means that there is no answer. Okay, there is no solution. So what we're going to write down is if you end up with a false statement. You don't write false. That's not the answer to the problem. The answer to the problem is no solution. So if you end up with a false statement, this means all the variables canceled. That's how that happens. All the variables canceled out. So if you end up with a false statement, the answer is no solution. Okay, it doesn't happen a lot. And in every problem that we did last week and the ones we did yesterday, it never happened. But if all the variables cancel out and you end up with a false statement, you want to write down no solution. So that's the answer to this one. So no matter what number you try to plug in for x, you'll never make the left side equal the right side. It's impossible. You could pick a positive number, you could pick a decimal, a negative, a fraction. I don't care what you plug in, it's never going to work. Okay, so that's a no solution. Any question on that one?
Wait.
Yep.
So with 4, since it doesn't equal, would you, instead of the equal sign, would you do like a squiggly equal sign?
So you want to keep the symbol the same as the symbol they gave you in the original problem.
Okay.
Yeah, so we don't want to change this symbol. I know what you're talking about, and we will use that symbol sometimes when we round the answer off. But in this case, we didn't do any rounding.
Okay.
Yeah. So yeah, we do use that symbol, just not in this problem.
Alright.
Okay. Any other questions on this? Yeah.
If you put in like -3 instead of 4 would work. Would be equal.
You mean if this was a different number?
Yes. If
So we're
that
gonna
was -3.
So yeah, we're gonna talk about that in example 3 now. So I'm gonna give you guys another example that I want you to try to solve, and I'll be able to answer that question once we do that problem. If you get to a point where again you have a number equals a number and all the letters cancel, just kind of wait right there for a second, and we'll check in with it. So give that one a try. It says 5 plus 3x minus 2x equals 4x plus 5 minus 3x. Now just to kind of give you a hint to start you off here, do you have any simplifying you need to do?
Yes.
Yeah, distributive property or combine like terms?
Combine.
Yep, you've got some like terms to combine. And remember, that's on the same side of the equal sign. Okay, so try that, and then see where you end up. Okay, so we said we do have simplifying to do, no distributive property, but we do have like terms. What are my like terms on the left? Yep.
3x and -2x.
So we're going to combine this and that. And what about my like terms on the right? Yeah.
4x and 3x.
4x and
-3x.
-3x. Okay. So we'll start on the left. Madeline, if I combine 3x minus 2x, what do I get?
1x.
1x. Yep. So you can put 1x or you can just put x. Same thing. Equals. And how about if I combine like terms on the right side? What do I get there?
1x.
So 4x minus 3x, yep, that's 1x. Or we could just, you know what, I'm just going to put x. Anything else on that side?
5.
Yep, plus 5. Okay, now we need to put all the x's on the same side.
-x on the right or left.
Yeah, it doesn't really matter. Let's just say we want to put all the x's on to the left. So to move that x, you would do what?
Subtraction.
Yep, and what did you subtract?
X.
X on both sides.
And we left with 5 equals 5.
Yeah, so this is gone. X minus x. That's gone. X minus x. And you're left with 5 equals 5. So all the variables are gone. So we need to stop at this point and figure out what that means. Yeah?
Means infinite solution.
Right. So I'm going to write something down like this. Except this time I'm going to write, if you end up with a true statement. Okay. So So that's a true statement. 5 equals 5. So if you end up with a true statement, and again, that would happen because all the variables canceled out. So if you end up with a true statement because all variables canceled out, the answer is, we say any number. Okay, the answer is any number. Or we can also say all real numbers. In math, when we use the word real, it just means a positive, a negative, a fraction, a decimal, or 0. It means anything. So the answer is all real numbers. Now, how many numbers are there? Infinite. So there's a little bit of a difference between saying the answer is all real numbers and saying the answer is infinite. Well, that's how many answers there are. There are infinitely many answers. But what are the answers? Any number. Okay, so you really want to write down either all real numbers or any number is a solution. If the question, which I don't normally do this, but if the question said how many answers are there, then you could say infinite. There are infinitely many. I usually don't ask that.
So Mr. Hager, if they're doing homework and they come across one that, 5 equals 5 or 10 equals 10, then should they write also all real numbers? What's the answer you want to see?
All real numbers.
Okay.
Yeah. All real numbers or any number is a solution. Yeah.
We know from just 5 plus x equals x plus 5, we know that it's going to just go, just simplify down to 5 equals 5. So would it be more efficient just to stop there?
Yeah, it's fine if you stop at that step because you can tell that it's going to be 5 equals 5. Once you get to that point, you pretty much know that the answer is all real numbers. Or again, you can also write any number. Yeah.
Are we going to use an infinite solution this year?
Are we going to what?
Using an infinite solution this year?
That would only be if I asked you how many answers there are. You would say there are infinitely many. But again, I generally don't ask you how many there are on this kind of problem. I usually ask you what they are, not how many are there. So there's a little bit of a difference in those two questions. Okay. Any other questions on this one? So we're gonna, since example 3, you had the whole back page, you probably didn't use the whole thing. We're gonna just finish up with the example we didn't do yesterday, which actually falls right in line with the same numbers we were using. Example 4. Okay, so we'll go through this one together. Okay, and we kind of did one like this in the warm-up too, so.
Not a wire sheet.
That's a lot. Okay, so if we're going to solve this one, is there any simplifying we have to do first?
Yes.
Yeah. What's the first thing we look for?
Distributive property.
Yep. Do we have distributive property?
Yes.
Yes, we do. What are we distributing on the left? We talked about this before.
Negative.
Negative. Yeah, it's like you're distributing a -1 on the left. And what are you distributing on the right?
3.
A 3. Okay, Sam, if I distribute the -1 on the left, what's -1 times 4?
-4.
-4. And Eli, what's the next thing I have to distribute the -1 to?
Why?
To what?
To why?
What kind of y? -1. So what do we get when you distribute -1 to -y?
Positive 1y.
Positive 1y. You just put positive y. Yep. Perfect. Okay, and on the right, Marie, the first thing I distribute this 3 to is 7. And Madeline, when I distribute the 3 to the 7, I get 21. Okay, Evelyn, next thing I have to distribute the 3 to?
2y.
2y. And Zach, when I distribute 3 to 2y, what do I get?
6y.
6y. Perfect. Now I can tell that this is not going to be one of the kind of situations we just talked about because I don't have the same amount of y's on each side. Okay, so this is going to end up being just a regular problem, not a no solution, not a all real number solution. Okay. Okay. So what would we do next? Adding and subtracting.
What I did was make it easier to subtract just the y.
Okay.
Because like that, you'd also go on the negative side.
Yeah, if we subtract the y from both sides, it'll stay positive, at least for now. So we get -4, and then we have 21
Plus 5y.
plus 5y. Okay, so the y's didn't cancel out like they did in the last 2 problems. So now, that means we still have more adding and subtracting.
Subtract 21.
Okay, we're going to subtract the 21 on both sides. 21 minus 21, that cancels. And how about Lily? -4 minus 21.
I need a calculator for that. Can I use James' calculator? -25.
Yeah, well, you can borrow one time too if you need one. But yeah, it would be -25. So yeah, -25. And what would still be on the right side, Lily? You're not Lily. That's okay. Yeah, you still have the 5. I appreciate the enthusiasm. Alright, so we get -25 equals 5y.
You
And then, yeah, your last step,
divide
divide by
5.
5.
And then it's going to be -5.
And 5 divided by 5 cancels because you get
-5. Oh, sorry. 1.
1, right? You get a 1y on the right. And you said on the left you get -5. Yep. Is it okay to leave the answer with the y on the right?
Yeah.
Yeah, that's fine.
It's the same.
It's the same thing. Yeah. So, for tonight, just to be clear on what the homework is, it's the 1.3 part 1 worksheet. And that's under lesson 4. We swapped 4 and 5. It's fine, it doesn't matter. Tonight is lesson 4 for the homework. Last night was lesson 5. Yep. Yes.